Bismillahirrahmanirrahim. Assalamu alaikum, student.
وعليكم السلام.
عليكم السلام ورحمة الله.
So last time we were solving the problems of chapter number 9, and we have solved the problems about the linear momentum, and impulse, and then average force for the Newton's second law in terms of momentum. And then we have seen some graphical problems about this impulse. So today first I will discuss with you the Coulombian. So in the Coulombian, you remember last time we have discussed the Coulombian is elastic and inelastic. Elastic and inelastic. So in elastic Coulombian, we discussed the one-dimensional Coulombian and the two-dimensional Coulombian. And in the inelastic, it is almost one-dimensional. So here I will solve this problem, and you can see and understand this type of problems. So here we have a body A, its mass is 4 kg and it is moving with velocity V in this way, and this is another body B, its mass is 12 kg and it is at rest. So it means its velocity is 0. So after colliding, then one body is moving in this direction and the other body is moving in this direction, and this is their line of motion. So this angle is theta and this angle is given 30 degree. So this is 4 kg mass and this is 12 kg mass. Its velocity is 6 meter per second and its velocity is 3.5 meter per second after collision. Now the question is, first question is, calculate this angle theta. Calculate theta. So to calculate theta, what we have to do? We have to write the equation in the x-axis and in the y-axis form. So first, to solve this problem, it's better and easy way to write the momentum equation in the vertical direction. Vertical direction means y-axis. So for vertical direction, y-axis momentum, this A body, it has 0 moment because vertically it is not moving. It is only moving horizontal. Plus this is also 0. It is already 0 because it is at rest. So this is equal to the vertical momentum after collision. Now we want to write that one. So this is the velocity direction, this is the velocity direction, and you can make the components of this one. So this component will be 6 sine of theta, and this component will be 3.5 sine of 30 degree. So we can write the equation. The upward momentum will be what? 4 into 6 into sine of theta. And the downward momentum is minus 12 into 3.5 into sine of 30. So we can solve this one. 0 is equal to 24 into sine of theta minus this is 42 into sine of 30 is 1 by 2. So this is 0, 24 sine of theta is minus, and this is cancel, and this is minus 21. So sine theta is equal to 21 over 24, and sine theta is equal to 7 over 8, and theta is equal to sine inverse 7 over 8, and this is equal to 61 degree. If you calculate, its answer is 61. So the angle theta is 61 degree. This angle is 61 degree. Okay. In the second part of this question is find this V. To find this V. So how we can find the V? So see in the next slide. So this is our A body, it's 4 kg and it is moving with V. And this is the another body, B, it is 12 kg and it is at rest, 0. And after colliding, one body is here, the other body is here. And this is their original line of motion, but this is deflecting. So this velocity is 6 and this is 4 kg and this is 12 and this is 3.5 meter per second. So we have found this value 61 and this is already given 30 degree. So we make the components like this one. Now we make the components in this way. Now the momentum along x-axis, momentum along x-axis. So x-axis momentum is what? 4 into v, mass into velocity, plus this is 12 into 0, 12 into 0 because it is at rest. And this is in this direction and this is 6 meter per second. So we can make the components. This is 6 into cos of 61 multiplied by the mass is 4 plus, and this mass is 12 into 3.5 into cos of 30 degree. So along x-axis, I have taken the momentum along x-axis. So this is 4v, this is 0. So this is 24 cos of 61 plus 42 into cos of 30. So you can solve this one for v value. So if you solve this one, the answer will be 12 meter per second. So in this way, you can find the value of v. One thing. This is the second part of this question. The third part is whether this collision is elastic or inelastic. Whether this collision is elastic or inelastic. So to find the elastic or the inelastic collision, what we have to do? We have to find the kinetic energy before collision. Kinetic energy before collision. And the kinetic energy after collision. So the first body, 1 over 2 m1 v1 square, m1 v1 square plus 1 over 2 m2 v2 square. So 1 over 2 m1 is what? M1 is this is 4 kg into V1. V1 we have found in the previous slide, it is 12 plus 1 over 2 M2 is 12 into V2 is 0 because it is at rest. So you can solve this one. So this is 2 into 144. This is 0. So this is equal to 288 joule. So kinetic energy after collision will be what? So kinetic energy of final after collision 1 over 2 m1 is 4 into 6 square, because after collision its velocity is changing, it is 6 plus 1 over 2 m2 is 12 into 3.5 square. So if you solve this one, you will get the answer around 145.5 joule. So it means this value and this value is not equal. So that's why the collision is inelastic. So in this way, you can solve the problems of elastic and the inelastic collisions. Okay. After this, now I want to solve the problems of our previous. Okay, let's see. I just share those problems. Yes. Okay, now you can see last time we have solved this problem, and now I want to solve this one. You can see this one. So here you can see that this is a 2000 kg truck. Mass is 2000. 2000 kg, and it is moving with a speed of 6 meter per second. Its speed is 6 meter per second, makes a 90-degree turn in a time of 4 seconds. So it means that it is moving in this way and then makes a 90-degree turn like this one. So this is VI and this is VF, and it takes this turn 4 seconds and emerges with the turn with a speed of, this is the final speed, and this is 4 meter per second. Now he is asking, what is the magnitude of the average resultant force? So to find the resultant force, what you have to do? You can find, first you can find the momentum, resultant momentum. So resultant momentum is equal to px square plus py square under root. So px is what? 2000 multiplied by vi, 6. It is 12,000 Newton into second. So you can write this 12 kilonewton into second. Okay. After this, then you can find the py. Py is 2000, mass is the same, and the 4, this 4. So this is 8000 Newton into second. You can write it 8 kilonewton into second. Now you can find this p value, and p value is 12 square plus 8 square and under root. And answer is 14.42 kilonewton into second. Now you can find the force. So this value divided by time is 4 seconds. So the answer is 3.6 kilonewton. So you can solve this problem in this way, or some another way. You can solve another way also. Okay, after this, another problem is this one. This is important problem. At 1.2 kg object moving with a speed of 8 meter per second collides perpendicularly with a wall. This is the wall. Okay. So the wall or the object is moving in this way. Its mass is given 1.2 kg. So with a speed of 8 meter per second. So its initial speed is 8 meter per second. So we are taking this direction, right, perpendicular. So 90-degree angle, and emerges with a speed of, so back is this one, and this is VF is 6 meter per second. So here you can see it is in the left direction. This is left direction and this is right direction. So right direction is positive and left direction is negative. Okay, so that's why I put it here negative. If the object is in contact with the wall for delta t time is 2 millisecond, and this is 2 into 10 raised power minus 3 second. What is the magnitude of the average force? So the average force is delta P over delta T. And this is equal to MVF minus MVI over delta T. So you can solve it. M is common over delta T into VF minus VI. So M is what? M is 1.2 divided by 2 into 10 raised to minus 3. VF, no, the problem is VF. So VF is minus 6, minus this minus. VI is 8. So you can solve it, and this is minus 14 into 1.2 divided by 2 into 10 raised to minus 3. So when you solve this one, you will get the answer 8.4 kilonewton. This is the answer. So here the concept is this one. If the body is you are taking in this direction and in this direction, then this will be positive and this will be negative. Similarly, if you are taking in this direction and in this direction, then this will be negative and this will be positive. So remember this notation. This is very important. Okay. So this problem is the same one which I have solved in the first on the open board, this one. So you can solve yourself. It's easy for you and try yourself. This is a good problem. Okay, let's see this problem. In this problem, the only force acting on a 2 kg mass is given 2 kg. If the velocity Vx is minus 2 meter per second at t is equal to 0. So at t is equal to 0, V of x is minus 2 meter per second. What is the velocity at t is equal to 4? So at t is equal to 4 seconds, what will be the velocity? So it means we need the final velocity, and this is actually the initial velocity. So what we will do? We consider this diagram. So in this diagram, before this diagram, we know that impulse is equal to delta P, and this is equal to mvf minus mvi. First, we develop the relation. I is equal to m is common, vf minus vi. And you can write I over m is equal to vf minus vi in this way. Now you need vf. So I over m plus vi. So in this equation, we have a value of vi, we have a value of m, but we don't know I. To find I from the graph, you remember this one, we find the area under the graph. So area under the graph will be what? Area under the graph is, if I draw a line here, then this is a rectangle. So its area will be 1 into 4. Thus, this is triangle plus 1 over 2 into base 2 minus 1, 1 into 4. Minus, because this is minus in the down, this one. So it is minus 1 over 2 into 4 minus 2 is 2 into 8. Actually, this is minus 8, but I put minus here. So this is 4 plus 2 minus 8. 6 minus 8 is equal to minus 2. So I put the value here. Vf is I is minus 2 over m 2. Vi is already minus 2 is given. So this is cancel. Minus 1 minus 2, and this is equal to minus 3 meter per second. So in this way you can solve this problem. So the important thing is you will take the impulse area under the graph. So in this problem is the same thing. You have to find the impulse under the graph and then solve it for the velocity. This is the same problem, and you can try yourself. Is better. Okay. After this problem, the speed of 2 kg object changes from this to this during a 5-second time interval. During the same time interval, the velocity of the object changes its direction by 90 degrees. So this is the same problem which I have solved like this one. So you can try yourself and find the magnetic magnitude of the force. So the magnitude of the force is what? Force, you know that mvf minus mvi over delta t. So apply this formula on this one and solve it. This is easy. So here you can see in this problem, a 3.0 kg ball with an initial velocity, mass is given 3 kg, and the initial velocity is given vi is equal to 4i plus 3j, collides with a wall and rebound. It means it is like this one and come back with a velocity final minus 4i plus 3j. So here the velocities are given just in the vector form, other is nothing. So the question is, what is the impulse exerted on the wall by the ball by the wall? So impulse is equal to change in moment, and m into vf minus vi. M value is given 3, vf is minus 4i plus 3j minus of this one. So this is minus 4i minus 3j in this way. So you can cancel this one, and this is equal to 3 into minus 8i. So minus 24i. So this is the answer. Okay. So in this problem, again, the ball is falling. If the ball is falling, the value will be negative, velocity will be negative. If the ball is rising, the velocity will be positive. And same, you can find the impulse is equal to mvf minus mvi. So apply this formula and solve it. This is easy, very easy. And you can, m is what? 2.4 and vf minus vi. You will apply this formula. Vf is this 1.5 and minus 2.5. So you can solve it. If the initial is minus, then it will be plus, okay? Because it's striking with negative and going, this is final. So final mean Vf minus of minus Vi. So it will be plus. So that's why I put here plus. So you can solve this one and get the answer. So these are the problems which I want to discuss with you. And chapter number 9 is finished. And if you have any question, you can ask me. So this is the chapter 9 end. So if you have any question, you can ask. Otherwise, see you in the next lecture if you have any question. Otherwise, you can solve know yourself and make practice and send me by email if you have any problem. Okay. Thank you.
Okay, thank you, Doctor.
Okay, salam alaikum.